Welcome back. Let's learn how to solve equations containing parentheses. Alright, so today we're going to learn how to solve the last type of basic equation in algebra, which is going to make use of all of our equation solving skills developed so far, but with a little bit of an extra twist. And so up to this point, we have looked at how to solve equations of these four different forms: x plus a equals b, ax equals b, ax plus b equals c, and ax plus b equals cx plus d. In each case, x represented the variable that we wanted to solve for, and the other letters a, b, c, and d represented constant values. Alright, and so you should be familiar with equations of these forms by now, but what we're going to look at now are equations that look similar to equations of these forms, but where they also contain parentheses. The equations are going to get a little bit more complicated. And so what do we do when that's the case? What if there are parentheses contained within our equation? How could we solve the equation for the variable? Well, let's take a look at an example. Here I have an equation that does contain some parentheses, specifically two sets of parentheses, right? The equation is 4 plus 5 times the quantity 2x minus 3 is equal to 3 times the quantity 4x minus 1. And so in this equation, the variable is x, and that's what we want to solve for, right? Our goal remains the same. When we are solving equations, the goal is to get it in the form of a variable equal to a constant, or the way that I like to say it is that we are isolating the variable. We are getting it by itself. And so we still want to do that here, but our method is going to be a little bit different. We first have to get rid of those parentheses. And the way we do that is by making use of the distributive property, right? We learned about the distributive property earlier in algebra. We can use the distributive property to simplify the variable expressions on both sides of the equation, which will remove the parentheses, and then we'll be left with some terms that we can simplify, and then will most likely be in the form of one of the previous types of equations we learned how to solve. Okay, so remember, the distributive property says that if you have some value, in this case a, multiplied by a quantity of another value b plus another value c, that would be equal to that value of a multiplied by b plus a times c. Okay, you can distribute that a through the quantity. That is exactly what we want to do in this equation. In each of these cases where we have a constant multiplied by a quantity inside a set of parentheses, what we want to do is distribute that constant through that quantity by multiplying it by each term inside. All right, so let's do that here. Starting on this side of the equation, there's nothing we can do to this 4. That's going to stay the same. So I'll write down 4 plus, and then distribute 5 through this quantity. We'll have 5 times 2x. 5 times 2 is 10. You can multiply the two constants, but keep the same variable part. So that will be 10x, and then multiply 5 by negative 3. And 5 times negative 3 is negative 15. So that's what we get on this side of the equation. But now let's see what we get on the other side. That is going to be equal to 3 multiplied by 4x minus 1. So we want to distribute 3 through this quantity. We're going to multiply 3 by 4x, and 3 times 4 is 12, so we get 12x. You keep that same variable part, and then 3 times negative 1 is negative 3. Okay, and so now, by using the distributive property, we have eliminated all the parentheses from our equation. They are gone. And so now what we want to do is just simplify each side of the equation as much as we can, and then our equations should be in a form that we recognize how to solve. Okay, and really the only thing we have to simplify here is on this side of the equation. Notice we have like terms of 4 and negative 15. Those are both constant values that we could add together. 4 plus negative 15 is negative 11. So we'd get 10x minus 11 is equal to 12x minus 3. Okay, and so now on each side of the equation, we have one variable term and one constant. This is an equation in the form of ax plus b equals cx plus d, an equation that we know how to solve from a previous lesson. Okay, so what we'll do here is combine our variable terms, because we only want to have one variable term so that we can solve for the variable, in this case x. So what we can do is add the opposite of one of those two variable terms to both sides of the equation. In this case, I'll choose to add the opposite of 12x to both sides, or in other words, subtract 12x. So if I do that here, minus 12x on this side, and on this side. And if you've been watching my other videos on solving equations, you know that I have been showing you to draw a divider below the equal sign to help you visualize the two sides of the equation. Feel free to do that, but by the end of this video, I am going to try and encourage you to move on from this. But for now, it's fine that we draw it. We can see on this side of the equation, 12x minus 12x will be 0, and so you'll just be left with negative 3. So we have 0 minus 3. And then on this side, 10x minus 12x is negative 2x, because 10 minus 12 is negative 2. But don't forget about that negative 11. We have negative 2x minus 11. All right, so now we just have one variable term, and so the next thing we need to do is isolate it. Let's get rid of this constant of negative 11 by adding the opposite of it to both sides of the equation. So I'm going to add 11 to both sides, and so these two 11s will cancel out, leaving you with negative 2x plus 0 on this side, and then over here, negative 3 plus 11 is positive 8. So we get positive 8 on this side of the equation. And then the final step here is to isolate the variable of x by dividing both sides of the equation by the coefficient, which in this case is negative 2. So we'll divide both sides by negative 2, and negative 2 divided by itself is 1. So you'll have 1 times x, which is just x, and x will be equal to 8 divided by negative 2, which is negative 4. That is the solution that we have found for this equation. X equals negative 4. Okay, so really not too much different than other equations we have solved in the past. It's just that there's an extra step of using the distributive property and then combining any like terms before going about our usual solving process. Okay, but let's check our work. Let's make sure that this really is the solution to this equation. Let's plug x equals negative 4 back into the original equation. If we do that here, we'll have 4 plus 5 times 2 times negative 4 minus 3 is equal to 3 times 4 times negative 4 minus 1. Okay, I just replaced each of these x's with negative 4. Now simplifying, you want to start with what is inside the parentheses first. Remember your order of operations. 2 times negative 4 is negative 8. So we have 4 plus 5 times negative 8 minus 3 is equal to 3 times 4 times the negative 4, which is negative 16 minus 1. Now negative 8 minus 3 is negative 11. So we have 4 plus 5 times negative 11. And that will be equal to 3 times negative 16 minus 1, which is negative 17. Now simplifying further, 5 times negative 11 is negative 55, so we have 4 minus 55, and that's equal to 3 times negative 17, which is negative 51. All right, and so then 4 minus 55, or you can think of it as negative 55 plus 4, would be negative 51. And so we get negative 51 is equal to negative 51, which is a true statement. And so x equals negative 4 is the solution to this equation that contains parentheses. Okay, so once again, remember, when you have an equation with parentheses, what you want to do to solve it is use the distributive property, simplify what's left over from that, and then solve your equation using the addition and multiplication properties of equations. Let's get some more practice with a different example. Hey there, real quick, before we get to the next part of this lesson, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's get back to the lesson. For our second example, we once again want to solve the equation and check the solution. This time our equation is 5y minus 4 times the quantity 3 minus 2y is equal to 2 times the quantity 3y minus 2 plus 6. Okay, so in this equation, we clearly have two instances of parentheses, or two sets of parentheses, and so that should immediately draw your attention and be the first thing that you want to work on when trying to solve the equation. You should try to immediately get rid of those parentheses using the distributive property. All right, so let's do that here. I am going to draw a divider below the equal sign, but then on this side, we're still going to have 5y, but then we're going to distribute -4 through this quantity. So we'll have -4 times 3, which is -12, and then that will be added to -4 times -2y. And so if we multiply the constants, -4 times -2 is +8, and then you want to keep that same variable part, so you'll get plus 8y. And so that's what we get on this side of the equation. But then over here, we need to use the distributive property again. We want to multiply 2 into this quantity. So you'll have 2 times 3y, and 2 times 3 is 6. So you get 6y, keep that same variable part, and then multiply 2 by -2, and you'll get -4. All right, so we have 6y minus 4, and then don't forget about this plus 6 on the end. Okay, so now we have gotten rid of the parentheses. The next thing we want to do is simplify by combining any like terms. Notice that on this side of the equation, we have two terms involving y, right? 5y and 8y are like terms. They have the same variable part. So we can combine their coefficients and get 13y, but then don't forget about the -12 there. Okay, so these were two like terms that we combined to get this single variable term of 13y, but then over here we have two constant terms that we can combine. -4 and 6 are like terms, and -4 plus 6 is 2. So over here we get 6y plus 2. All right, and so now we have an equation where each side has one variable term and one constant term. And that is a type of equation that we are familiar with solving. The first thing we want to do is get rid of one of the variable terms from one side of the equation. In this case, I think I'll get rid of this 6y by adding the opposite of it, or by subtracting 6y. So if we do that on both sides of the equation, these 6y's will cancel out, and you'll just have 2 on this side of the equation. That 2 is all that's left over. And then over here, 13y minus 6y is 7y, and so we have 7y minus 12. And now we just have one variable term, so let's isolate it. Let's get rid of this constant term by adding the opposite of it to both sides of the equation. The opposite of -12 is +12. So we'll add 12 to both sides of the equation. On this side, -12 and +12 cancel out to be 0. So we're just left with 7y on one side and 14 on the other, because 2 plus 12 is 14. Okay, and so I'm running out of space here, but this step right here would translate to this equation. 7y is equal to 14, right? That's where we're headed next here. Our final step to solve for y is now to divide both sides by the coefficient of that variable, which in this case is 7. So if we divide both sides by 7, those 7's cancel out, leaving you with y is equal to 14 divided by 7, which is 2. And so y equals 2 is the solution that we have found for this equation. But now let's check it. Let's see if we did our work correctly. We want to plug 2 back into the equation. If we do that, here's what we'll get. 5 times y, which is 2, minus 4 times 3 minus 2y, so we'll have 2 times 2, and then that will be equal to 2 times 3 times y, so 3 times 2, minus 2, plus 6. All right, now simplifying, 5 times 2 is 10, so we have 10 minus 4 times what is inside the parentheses here. We have 3 minus 2 times 2, which is 4, so 3 minus 4 equals 2 times what's inside these parentheses, where we have 3 times 2, which is 6, so 6 minus 2, let's write that down, and then we still have plus 6. Next, 3 minus 4 is -1, so we have 10 minus 4 times -1 is equal to 2 times 6 minus 2, which is 4, and then we still have plus 6. And then -4 times -1 is +4, so we have 10 plus 4 equals 2 times 4, which is 8, plus 6. And then 10 plus 4 is 14, and so is 8 plus 6. So both sides of the equation are the same value. 14 equals 14 is a true statement, which means that y equals 2 is in fact the solution to this equation. We did our work correctly. Okay, so this check work does take a little bit longer than it used to because our equations are more complicated than they once were, but regardless, we could still check our solution and found that it was correct. Let's take a look at one more example for this video. For our last example, we once again want to solve the equation and check the solution. This time our equation is -2 times the quantity 3z minus 5 times the quantity 2z minus 3, all equal to 3z minus 8. Okay, so this equation does look a little bit more complicated than our previous two because we have a set of parentheses inside another set of parentheses. And so while that does look tricky at first, don't get too overwhelmed. Just take it one step at a time. We're still going to use the distributive property to remove those parentheses. We just have to pick one set to eliminate first. And I'm going to pick the inside here, okay? We can get rid of this set of parentheses by multiplying -5 by both of these two terms. We'll multiply -5 by 2z and -5 by -3. So here's what we'll have. -2 times 3z plus -5 times 2z. -5 times 2 is -10, so we have minus 10z. And then we'll add that to -5 times -3, which is positive 15. Okay, once again, we multiplied -5 by 2z and -5 by -3. And then on the other side of the equation, there are no parentheses. We just have a variable term and a constant term, so I'm going to leave them as they are. And for this example, I'm also going to ditch the divider that I had been drawing below the equal sign when we solve equations. With this example and the examples in the examples video for this topic, I'm going to encourage you to try to graduate from using that divider bar and instead just rewrite the equation each time you make a simplification when trying to solve it. Okay, I'm hoping by this point you're familiar enough with equations that you can move on from using that, as it will make your work easier in the future. Okay, I just find it to be a nice visual early on, but we're sort of beyond those stages at this point. But anyway, moving on to the next step, we still have a set of parentheses that we need to remove before we can solve for the variable in this equation, which is z by the way. And so to get rid of these parentheses, we have to distribute -2 through this entire quantity. We have to multiply it by each of those terms. All right, so you want to multiply -2 by 3z, you want to multiply it by -10z, and you want to multiply it by positive 15. So if we do that, -2 times 3z will give you -6z, because -2 times 3 is -6, and then you keep that same variable part. Then -2 times -10z will give you positive 20z, because -2 times -10 is positive 20, and then you keep that variable part of z. And then -2 times 15 is -30. And so that will all be equal to 3z minus 8. Okay? And so now we have gotten rid of all the parentheses. Our last set of parentheses is gone. Now we just have an equation that we need to simplify before trying to isolate our variable. All right, and so this side of the equation is good. Once again, 3z and -8 can't be combined. We just want to focus on this side right now. And we can make a nice simplification. Notice that we have two like terms. -6z and 20z have the same variable part of z, so we can combine the coefficients. -6 and 20 is positive 14. So we get 14z minus 30 is equal to 3z minus 8. So now, to isolate the variable, we want to combine those variable terms. So let's get rid of 3z on this side. Let's subtract 3z from both sides of the equation. That will cancel out with this 3z on that side. And so you'll have 14z minus 3z, which will be 11z, because 14 minus 3 is 11, minus 30 equals 0 minus 8, which is -8. All right, and so now we want to combine the constants to isolate the variable term. So now what we want to do is add 30 to both sides of the equation. That way -30 and positive 30 cancel out, just leaving you with the variable term. And so continuing our work up here, we'll have 11z equals -8 plus 30. 30 minus 8 is 22, so this is equal to 22. Now, we can isolate z, or solve for it, by dividing both sides by the coefficient of 11. So we'll divide both sides by 11. Those 11s will cancel out, and just leave you with z is equal to 2, because 22 divided by 11 is 2. And so the solution we find here is z equals 2, but let's check it. Let's see if that really is the solution to this equation. Let's plug 2 in for each of those z's, and if we do that, here's what we'll get. Negative 2 times 3 times z, which is 2, minus 5 times 2 times z, which is 2, minus 3, and that's equal to 3 times z, which is 2, minus 8. All right, now simplify what's in the parentheses first. We'll have negative 2 times 3 times 2, which is 6, minus 5 times 2 times 2, which is 4, minus 3, right? So we have 4 minus 3, but that would just be 1. So next time when we simplify, we just have 1 times negative 5, which is negative 5, but that's equal to 3 times 2, which is 6, minus 8. All right, and so then simplifying further, we have negative 2 times 6 minus 5, right? This is just 1. 1 times negative 5 is negative 5, and then that will be equal to 6 minus 8, which is negative 2. And then finally, negative 2 times 6 minus 5. 6 minus 5 is just 1, so you have 1 times negative 2, which is negative 2. So you get negative 2 is equal to negative 2, which is a true statement. That means that z equals 2 is the solution to this equation. Okay, and so this was the last example for this lesson video, but if you do want to get some more practice solving equations with parentheses, feel free to check out the examples video for this topic that I'll have linked here on the screen. If you have any questions, please let me know in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.